Hello class, this lesson is entitled Isosceles and Equilateral Triangles. Well, to begin with, let's review a little bit. What is an isosceles triangle? An isosceles triangle is a triangle with two congruent sides. Now, some people argue that it's only two congruent sides. Some people can say it's at least two congruent sides. But we're going to say right now a triangle with two congruent sides. Because when we have all three, we're going to call it equilateral anyways. So there's no point in saying at least. So just two congruent sides. Here we have the isosceles triangle theorem. Now it says if two sides of a triangle are congruent, then the opposite angles of those sides are congruent. So again, if we know that AC and CB are congruent, that means these, what we're going to call them base angles, those two are going to be congruent to each other. Okay? Now the converse of that, and we talked about converse back in chapter 2, we switched the hypothesis and conclusion. If two angles of a triangle are congruent, then that would prove that that the sides opposite those angles are congruent. Okay, so again, these two sides, if we know these two base angles are congruent, that means these two sides will be congruent. So we have the original isosceles triangle theorem, which says if the sides are congruent, then those two base angles are congruent. The converse says if we know that the angles are congruent, then that means this opposite sides will be congruent. Okay? And lastly, we have theorem 4.5. It says the bisector of the vertex angle of an isosceles triangle. Now, the vertex angle of an isosceles triangle. What that means, it's the angle that is, it's the angle of the triangle that is not opposite one of the congruent sides. So basically it's going to be in between the two congruent sides. Now the bisector of that is going to be perpendicular with the base. So it creates a right angle down there. Okay? Alright. So we're going to use these to work on some two-column proofs. So here we go. We're going to prove the isosceles triangle theorem. That says if the two sides are congruent, then the two angles, y and z, are going to be congruent. So, what do you always do on a two-column proof first? You always write the given. So there we have it. We're given that xy is congruent to xz, and we're given that xb bisects angle yxz. So again, we want to make our markings. In this case, it's already done, but just to reiterate, xy is congruent to xz. So we make the marks. It's always good to make the markings on your diagram. Now, as I've taught you before, the first thing you should always look for in a two-column proof is shared sides or vertical angles. So in this case, we do have shared sides. Okay, we do have XB right here. These two triangles share that side, so we get to write that. XB is congruent to XB. If we remember correctly, that property is the reflexive property. Okay, again, when they share a side, we could say that side is congruent to itself, and that's the reflexive property. So notice we have two congruent symbols already. We make our marks. So we have those two sides. Now we have that pair of sides that are congruent to each other. So we have two congruent symbols. Remember, we need three before we can prove the triangle is congruent right now. So once you're done looking for shared sides and vertical angles, which there are no vertical angles on this one, we look to the given. Is there anything in the given that is not a congruent symbol? Of course, we see the word bisects. Again, what is being bisected? Bisected meaning cut into two congruent parts. Here the angle YXZ is being bisected. So if you look at YXZ, so where X is the vertex, that's being cut up into two angles. Now that means this whole angle is being cut into two, angles 1 and 2. So those have to be congruent. So let's go ahead and write that. Okay, angle 1 is congruent to angle 2. Why? Because that's what a bisector does. That's the definition of a bisector. It bisects something. It cuts something into two congruent parts. I had to shrink down the diagram to make my reason fit. So now notice we have three congruent symbols. So we have a side, We have another side. Oop, there we go. And we have, my pen's not writing, an angle. So the combination of two sides and an angle would be side, angle, side. Because again, when in doubt, just look at your diagram. You'll notice if you only look at the left triangle, the angle that is marked, angle 1, is directly in between the two sides that are marked. So this would be side, angle, side. So let's write that. There we go. Triangle YXB is congruent to triangle ZXB. And remember, you have to match up the correct angles. So Y matches up with Z, X matches up with X, B matches up with B. The order of how you write those triangles does matter. And again, our reason was side, angle, side. And lastly, we're trying to prove that Y is congruent to Z. Well, if we know now that the triangles as a whole are congruent, we can go ahead and say angle Y. I can't write. Sorry. Let's try this one more time. There we go. Angle Y is congruent to angle Z. Again, the triangles as a whole are congruent. That means each corresponding part is congruent. So again, our reason is CPCTC, which says and means that all the corresponding parts of congruent triangles will be congruent. So since we've proven that the triangles are congruent, we can say each corresponding part from one triangle to the other is going to be congruent. So we've now just proven the isosceles triangle theorem, that if two sides of a triangle are congruent, then the angles opposite those sides will be congruent to each other as well. Okay? Let's move on. Now we get to use that theorem. So here it says find the value of y. So you are given that these two sides are congruent to each other. Now it also says that angle LMO is congruent to OMN. So these two angles are congruent to each other. Alright? Now, since these two sides are congruent, we also know that these two angles will be congruent to each other. That means that angle N is also 63 degrees. Now, how is this going to help us? Well, also, with our other theorem that we also learned, that since this is being bisected, notice again, those angles are congruent. That means this has to be perpendicular. So that's a 90 degrees right there. So now we have our triangle. We have one triangle that we're going to look at. We have this one right here. Every triangle, again, is 180 degrees. So if that's the case, we know we have 180. Now, if you take the two angles that you know, which is 90 and 63, and we add those together, that gives us 153. So to find y, we just subtract 153. And that leaves us with 27 degrees. Now, if you wanted to set that up as an equation, we would say y plus the 153 is equal to 180. In the end, you would subtract the 153 over. So y is equal to 27. Okay? There you go. So since we know the isosceles, we know those opposite angles are going to be congruent to each other. Okay? And again, the other key thing is if M, angle LMN is being bisected, that means this segment going down the middle is going to be perpendicular, which gives us a 90-degree angle at the bottom. Okay? All right. Now let's move on. What is a corollary? So another vocab word here. I will not put this word on a test, but it's important to know what a corollary is. A corollary is a statement that follows immediately from a theorem. So we have our theorems, and then from that we can come up with what we call a corollary. So we're basing it off of the theorem. So here it says corollary to theorem 4.3. And again, 4.3 was saying if two sides of a triangle are congruent, then their opposite angles are congruent. Well, we can build even further from that. So we have corollary to theorem 4.3. It says if a triangle is equilateral, so now all three sides are congruent, then all three angles are going to be congruent to each other, not just the two, but all three will be congruent. So if it's equilateral, it's also equiangular. And if you flip that, if it's equiangular, then it has to be equilateral. Okay? Now we need to explain why each statement is true. Now the first one says angle VWS is congruent to angle S. How do we know that? Well, with this first one, again, if we look at these markings, here we have little triangle, okay? Oh, sorry about that. We have a little triangle VWS. That's an isosceles triangle. So the fact that that's an isosceles triangle means their angles opposite, I'll do a different color, opposite the congruent sides will be congruent to each other. So that's how we know that angle VWS is congruent to angle S. Okay, they're both base angles across from the congruent sides. Now also it says TR is congruent to TS. How do we know that? Well, if you look at this as a whole, now that we've established that angle S is congruent to this one, notice that it's the same amount of markings as angle R. And again, markings are so important. That means I'm going to go ahead and erase this triangle. That means angle S and angle R are going to be congruent because they have the same amount of markings. So now we're going to look at the triangle as a whole. So if we have this triangle now, since our base angles are congruent, okay, our base angles are congruent, that means the sides directly opposite those angles, so this side, is going to be congruent to this side. Okay? So again, since the base angles are congruent, the sides opposite them are congruent. I suppose I should have wrote that for the one before too, just in reverse, so here you go. There we go. Sorry. Since the two sides are congruent, this is back to the first one, since the two sides were congruent of the little triangle, then the opposite angles to them are congruent. And again, for the last one, since the base angles were congruent, therefore the sides opposite them are congruent. So I hope that helps your understanding of isosceles triangles, again, and their base angles, the angles opposite their congruent sides. So good luck with that, and I hope that helps.